Hello everyone, I'm Gang. In this lesson, we will briefly get into generating a dynamic object and then synchronizing this object. This step is very prone to errors. Don't worry about these for now. They're all just filler. The main point is to spawn an actor on the server. If this class has replication enabled, then the spawned class will be synchronized to all terminals. When the server destroys this actor, if the actor has replication enabled, then all the spawned actors associated with it will also be destroyed. So we'll make a simple demo here. Let's first demonstrate the correct way it should be done. So let's give it an actor. We'll call it BP Charles White. Replicate. We'll just write the name casually. Then we'll give it a static mesh. We'll just pick any static mesh. Let's give it a sphere. It is such a sphere. Then inside this sphere, we enable the synchronization option. Note that you need to select it here, because if you have a static magic, you don't have this. Because our synchronization is all based on this, we just need to make it replicate. We just need to make it synchronize. Okay, that is, if this object is dynamically generated, it will synchronize. Okay, so here we give a collision box. When we let the player walk to this object, we make it spawn an object. Then, here, give another actor. We call it ABP. We call it span box. So this span box, first, we need to add a box, a collision box. This is a collision box. Then here, give a cube. For this cube, we compress it like this. Okay, this way we ensure we can step over it because it's like this. Okay, let's first check if he can step over it normally. Let's check the collision. Here, then we give a print. We need to give an overlap. Give an overlap. So this should be this box. This is blueprint knowledge. It should be relatively simple. So when we have this overlap, let's take a look. We give a hello. Then we arrange this overlap in the level. Let's put it here. Okay. Okay, let's put it here. Then this character class of ours. We still use the previous one. We ensure, evidence proves that it collided on both the client and the server. Then suppose we will spawn a drop item here. Right, let's spawn a drop item. Okay, so what is the correct approach? It actually works like this. That is, when a collision occurs, we write it like this. A collision occurred. Then we can do some. For example, the cast is, let's cast this. Because we might have other collisions, we avoid this issue. This should be the 003 actor. If the conversion is successful, this should be used sparingly. This node should be used sparingly. We generally don't use it this way. We can only do it this way as a workaround. Then if the cast succeeds, we spawn an actor in the scene. Spawn actor from cast. Then we select BP for this class. Let's see what the name of this class is. Wait a moment. This class should be called writeReplyTick. Let's find BP. writeReplyTick. Okay. Then we set it to always spawn. That is always spawn and ignore collision. Okay, then we adjust the position. Here we can say, we make it make transform. Then for the collision position, let's select the position of this collision point. Get actor location. Then we split this part. After we split this part, we set XY like this, and then we spawn one on top of it. We need to add 100 to this. This means once overlap occurs, a sphere like this will be generated here. Okay, so this is the correct logic. Of course, it's best to disable the sphere's collision here. Because if we don't, it might cause some strange issues. Here we disable collision and set it to none. no collision. Okay, here we are. We are currently running it in a single instance manner. You should be familiar with this method. It will generate a sphere here, right? We'd better adjust its position. This way, if it collides multiple times, we can take a look from above. Okay. Hey, we didn't hit it, did we? Let me check. You can see on our right, it has actually been generating. Right. Yes, it has actually been generating this object. Okay, so this is actually correct. If we are on the client side, we need to make this ball a bit smaller. We change this ball to 0.2. This way it is small enough. Okay, you see this ball should be generated repeatedly. We can give it a random number. That is, this position might... It's not good that it always spawns at this position. Yes, let's change it again. Okay. We just roll this number casually. It should be fine. Then we do it like this. Then when clicking like this, there is absolutely no problem. No problem at all. Then let us explain, in a network situation, what kind of problem will arise. We set it to network now. Set it to network, then we do it this way. We'd better do it inside tick. Do it inside tick. We use get actor of class. Then we get all the BPs in the scene. Such a sphere. Then we should use get actor of classes. We need to get all such spheres. Let's see what this thing is all about. How many are there in the scene? Okay. We only need its quantity. Let's print this number. Then we only print it to the screen. We only print it to the screen because this number is too large. It would be troublesome if it refreshes every level. We don't print it to the log. We set its duration to 0 seconds. This way it only refreshes for 1 frame. Okay, now let's run it in single click mode. One occurred, right? 2, right? 3, right? It looks okay. What if we do it this way? We proceed in this client-side manner. Let's check. The server's clients are all 0, right? Hey, why? Why are there 2 clients? Hey, or you notice that the client actually... Right, why is there double? Well, it's actually very simple. The reason is that you checked repractic, and when it generates, this type of object should only be allowed to be spawned on the server. So, if you spawn one on the client side here, and you spawn one on the server side, then actually if we open another one now, let's take a look, right? You'll see it's still double, right? So this double situation is quite special. It actually works like this. There is one on the server. There's only one on the server, and there are 2 on the client side, and these 2 on the client side, one comes from the server. Another is generated locally in world 1, and the other one, the other world 2. It has one from the server, and the one generated locally in world 2. This should be understandable. The concept of local generation in world 2, understanding it this way should be fine. Okay, to the correct approach is that you should actually be here. At this point, we will check that we must be on the server. We can use this function here. 卡包 EC DT key server. Okay, server. So we just need to check whether it is currently on a dedicated server. You can see this is a light mode. We used this for you earlier. You can see we only let it spawn on the dedicated server. Okay, here we are. We can write it a bit earlier. If it is not on a dedicated server, we simply do not act right. Now let's execute it again. Take a look at the effect. You will find that doing it this way, no matter how you do it, it only spawns this object, right? Obviously, when this object is destroyed on the server, then the corresponding object on all other clients should also be destroyed accordingly. So, if we want to simply implement a destruction, we can Let me check this destruction. When we leave, we will destroy it. This is also quite simple. Okay. So here, through this place, we only destroy it on the server, right? That is for this bullet. It's the same here. When the overlap ends here, because we only have this one object now, then we will spawn such an actor here. We can promote this actor to a variable. We give it a... If we use just this one name, let's change the name to my Sophia. And actually, we also need to prepare a host here because we might want to collide multiple times. Then we set this as a host. Set it as a host. Then move it here. We call it Sophia Oric. Then we add it in. Add. Okay. Let's see what this warning generally means. Okay, no problem now. Then when we end the collision, we need to iterate through this thing inside. We take all the generated spheres. There might be multiple, right? Then we set them if they are available. We just detour it. Okay. So for this step, we will definitely only do it on the server. At the very end, we must clear this host sense. Because we have already released all of it. Clear. Okay. Alright. This is a simple logic. Now let's execute it again. We'll open one client. Opening 1 or 2 is actually the same. We'll just open 1. We'll open 2. To make it easier for everyone to see. Alright. We are now colliding. We remove it. This doesn't seem to have been destroyed. Let's check the reason. The reason should be this. It seems we used the wrong test object. We should be using a box. It should be a box. This underweb, because it has... We used a cube instead, so that's incorrect. This is where the error occurred. Okay, let's test again. Let's just test with one player. For now, we can see. We have generated it. We have entered. This place can be ignored. It can be seen. We have successfully removed it. We have entered again. We have successfully removed it again. Right. We enter again. We remove again. Then, after we open multiple players, everyone can experience a control of this life cycle. You can see that we have the client. We are here. Right. Generated. Remove. Generated. Didn't touch. Generated. Removed. Right. So the knowledge in this section mainly emphasizes this. When we dynamically generate an actor, we must enable repractice. Then we only do it on the server, spawn and destroy it, and not on the client, unless we have some shade. There are some things that only exist on the client side. Only then will we do it this way. But if you do it this way, you must be careful not to affect your game logic. So in this lesson, we mainly want to emphasize to you that this replication is meant to create a network replication relationship. Okay, so that's all for this lesson. And as for the wrong approach, you should already know how this wrong approach comes about and how to avoid it.